I'm psyched to be here at the Angular meetup. It's good to see some familiar faces here at the React meetup and at a place that's very dear to my heart, Backstop. So this is a talk about more than just the view layer. It's about distributing the awareness of what's going on across all connected apps and clients. I'm Dean Radcliffe. I work here in Chicago, not Silicon Valley. Have worked at Backstop Solutions, holla. Currently working at Discovery Education, and I've been moving through different industries, and educational technology, or EdTech, seems to be the one providing me like the most interesting challenges here. The thing that's come out of my work in EdTech is this little mini platform called Antares. We've been using it in production for almost since December. It was kind of really first crystallized in December, but an open source version of it that has none of the internal tips and tricks that we have, nothing proprietary, is available at this URL and a couple of sample app repos. And then here's the buzzword soup that almost became my talk title. But I mention Redux, RxJS, MeteorJS, GraphQL, Element, Apollo, because a few of those, the first few, are actually incorporated into Antares, and you're using them if you use Antares. And the other ones just have a philosophy that I think is consistent with Antares. So if you like any of those, you might like Antares. If you like solving these kinds of problems, you might like Antares. You want real-time sites and apps. That means mobile apps. You want to rethink REST. You're not satisfied with data being far away. And if you know something at the server, like an item has gone out of stock, why not notify all connected clients? Like, just connect to clients, use full duplex communications, so that, you know, in educational technology, the consumers are students, right? So you're fighting for like the shortest attention spans in the world. So the content's got to come to the user like a game. It's got to be engaging. So that's kind of the environment from which Antares arose. And then by using some of the building techniques that we have in Antares, it turns out that we've completely decoupled from databases. And I don't mean like there's an abstraction layer like Active Record over database A, B, or C, but meaning your app can run even if it doesn't have a database at all. It's not like your first part of building the app is doing a create table statement. So I'll show you more about that. So instead of a to-do app kind of app as the hello world, I'm using chat as a hello world. It's familiar to everybody. It has some very cool and subtle features that show off Antares, like that typing indicator that you saw go and then come back, and then it's going to go there. And when they send the message, the typing indicator goes away. And this is some tricky stuff to get right if you're not using some of the techniques in Antares. So it is a Redux app at its core, but I'm not going to really get into the specifics of building your first Redux app. Is anybody comfortable with Redux here? All right, we got a little less than 50%, so it'll be, you'll have to just kind of take it on faith, because I'm not going to get into the basics of a Redux app. I'm going to stick with like the advanced cases that Antares tends to solve, and it does so by doing this, embodying this beautiful philosophy that everything is a stream, because most frameworks that we use today deal with one incoming request at a time, not a stream of requests. So simple questions like, hey, I was processing this request. What other requests came in while I was processing this? You can't ask that question. You don't have access to an object that represents all the requests. So I think everything's a stream. So does this guy. So I'm going to go with that. I also think, and it's part of an RxJS thing called the observable contract, but that nothing is simultaneous. If two events come in like darn close to each other, just make a call like an umpire and just serialize them. That's what streams require, so just go with that. And this is the model of eventual consistency that Antares gives you. At some point in time, do we need the laser? Lasers are fun. At this point in time, server, client 1, and client 2 all know that the same actions have occurred, actions 1 and 2. Client 1 originates a new action, Eventually, it makes its way into the server. Eventually, it makes its way into the other client. 3 streams. Look familiar? It should, because you append to streams all the time. In fact, your employers don't even allow you to delete source code or update source code. All you can do is append new commits to source code. And that is the model that Antares embodies, and it'll help you think about things. If you think about appending immutable truths to a stream. Once you have streams everywhere, well then, you get to use RxJS, which Bill knows, and Bill's like, this is the reason you can talk tonight, is because I want to hear more about RxJS. It's like the Lodash of async. It's like the Swiss Army knife of streams. It just gives you the tools to manipulate the events on the stream, both simple things like doubling each event if it's a number, to actually changing their timing, batching them, throttling them, debouncing them, really advanced stuff that you'd be hard-pressed to code as cleanly any other way. I will do a brief summary of the Redux architecture just because Antares uses it principally, and it also does a few things differently. So in the very center, you have a store. That's an object, a JavaScript object that keeps track of the state for your JavaScript process. This means your browser process, your server process, whatever. All the things that you know about are in a thing called a store. And you submit things called actions to it. And in Redux, you use a method called dispatch. In Antares, I've renamed it to announce, because we're talking about multiple things. So you want to announce it so that it spreads widely. You announce an action into the store. The store sends the current state of the store and the action into a function called a reducer. A reducer is a pure function. Raise your hand if you like pure functions. They're very easy to test, and they are not database specific, which helps you achieve decoupling from your database. So your action and your old state go into the reducer. The reducer typically combines the old state and the new action in some way. It can do anything it wants. It can return anything it wants. But typical is to take some parameter of the action and embody it into the state, like the color. Send that new state down back into the store, and the store remembers it. In a normal Redux, you're done. However, Antares says, if you've got streams everywhere, then maybe there's a stream of states of the store. And if there's a stream of states of the store, maybe there's an operator to take the last 2 of them, compute a difference, and then translate that into an update command for your database. So that is, in fact, what Antares does. So you will never write, even if you're using Mongo as your backend, you will never write a Mongo update statement. You will just compute new versions of the store with reducers, and Antares will figure out your Mongo diff for you. It's pretty fancy. That's a pseudocode of what is going on in there. Any questions on this? Cool. So now the architecture that this fits into, the client architecture of an Antares app has a few different things. So the thing in the middle is that Redux architecture that I showed you. What flows into it are actions, right? Actions, 1, come from actions taken by the user. They added an item to their cart. This is typical Redux. You create and dispatch an action. But Antares is about awareness, right? So you're also aware of others' actions, right? So you have a stream of your actions and a stream of other people's actions, and they both get fed into Redux. Now, out of number 3, that's your communication to the server, and other people's actions don't need to go back to the server. They came from the server. So only some actions like this go down from number 1 and out to the server, but all of the actions that come into here will affect your UI. Now, why did I use a database icon? Everyone knows a cylinder is a database. Well, your UI, your DOM, is kind of persistent. It's slow to talk to. And so in short, it carries a lot of the characteristics of a database. And I even use the term rendering to talk about rendering to the UI or rendering to the database. So React just is getting this new rewrite, Fiber. And I think some of the things that it does internally is clever batching and reordering of operations to make things more performant. So your UI may be async, the user won't typically know it if it's 0 milliseconds later or 40 milliseconds later. If you need to do that for batching for performance reasons, you can make your UI updates async. So something async, potentially async, or potentially synchronous changes what's in the DOM. So that's your client architecture. You ready for the server architecture? It's going to be so different. There. And want to see that again? So that's why the red cylinder is your database, because it has the same problems. It's slow to talk to. You may, for operational reasons, choose to delay, batch, defer your database operations. I know that's kind of heresy to some people. It's like, no, you get the request, you have to write synchronously to the database. But believe me, every type of app does not require that philosophy. So why have synchronicity be hard-coded into your application if you can choose whether to add it in or not? So the only difference here is that the endpoint, the server receives actions from all the different users. That's very similar. And then this was inspired by MeteorJS, that if the database itself changes records, you can get those diffs available to this process. So the way this works in Meteor, which I'm not going to talk too much about, is that it follows the Mongo op log. So if you want to be able to publish not only actions that users take, but actual changes to the database, this architecture will support that. And then, of course, the actions that you have processed or are queued up for processing, can go back out your publication of all the actions of your process. And that's pretty much what an isomorphic architecture looks like to me, is that the two coincide in shape. So now I've got the unenviable job of getting into some live coding, where we talk about a concept that's very dear to my heart, and that is that of renderers. So you're changing the store, and you're computing the diffs from each successive state in the store. So at some point, something has to go and cause something in reality to change. And I'm calling that a renderer. So let us go to this chat application. And we take performance testing pretty seriously. So there's been a couple of load testing scripts that actually turn out to be pretty handy to automate a conversation happening. And so I can run this script, and you can see a conversation happening in this chat with a lot of asynchronicity, right? There's like a little random interleaving. So the first renderer we're going to add is going to be, well, did you notice that it didn't scroll down as the messages came in? That's lame. Even Slack scrolls down as messages come in. Wait, did I say that? Yes. So we're gonna write a renderer that does something about this. So we're gonna open up the code base and put it over here and get the font size good. And okay, I'm gonna have to look at my screen. Open up this. Okay, so a good place to do this would be in this client entry point. So this is just code that sets up the client as a whole, and we're going to add something to it. So let's see, import some things from Antares. We're going to import, the Antares object itself, and then, is that right? Yeah, that's what it looks like, right? And then we're going to, define a function. Scroll to bottom is going to be a function. So we talked about these streams, right? But I didn't really say what's on the stream. Well, one of the things on the stream is the action that was just processed. So our actions have names. This particular one is in a file called actions. We have an action called message.send. All right, that's what's going on when the UI is getting updated. So we're going to write a function that takes each item on the stream and plucks the action field off of that item. And then we're going to say if the action type is message.send. Then window, which is available because this is only client code, scroll to 0.document.body.scroll height. Boom. So now we will put Antares back up here. It clears its chat each time it restarts, just for demo purposes. And now we'll run the load test again. And of course, this is live coding, so that doesn't work. What's going on here? Did I save? Oh, you know what? I wrote a function and I didn't. Thank you. I didn't do anything with that function. What I should do is subscribe this fancy renderer function to scroll to bottom. Subscribe the renderer. There are options, but I'm omitting them for this purpose. All right. And let's just do a reload, and let's do, open up the server-side shell, because it'll allow me to restart the server like this, boom. And then I'll continue doing load tests. And this is npm run. When I do nrun, I don't know if you can even see the text in that black on window, but there we go. We've subscribed our first renderer. Scroll to bottom. Thank you very much. Oh, did I mention there's no database in this yet at all? Like, there's no database in this yet. So maybe, should that be the second renderer we add? Should that be the second renderer? Do you guys want to see a database going on here? All right. Or I could do Twilio. I'll do Twilio at the end, to just prove the point that it really doesn't matter what you render to, just that you have a function that runs on each item that comes through the stream. Wow, flattened children error. As a parent, that warning just really rubs me the wrong way now. But nonetheless, because I took a shortcut. I can point out that you're seeing the server logs down here. So if you want to look at 4 windows, this log down here is all of the messages that have been seen by the server. We'll talk about messages that are not seen by the server in a little bit. All right, so the way that we can do this, the way we can render to a database, well, I've set up a Mongo Labs database here. So the messages that I type are going to appear here. Right now, it's just an empty record. So I'm using a remote database just for funsies. And so when we start this up, I got to get this right. I think we call it. There's an environment variable that you pass to the process. And I believe I defined one called demo Mongo URL. So that's just to provide the underlying layer with knowledge of where the Mongo database is. And then we can go to the server side, and we can do a few things here. So what do we have to do on the server? We can say import Mongo from Meteor Mongo. So we're not hard-coded to Meteor in the long run. At the moment, you can run your client application. It doesn't have to be a Meteor app, any kind of app. Create React app. I have a demo app for that. But at the moment, the server is MeteorJS. It's a one-command install, and it does favor Mongo, but Antares itself, which we have an issue in the repo to code it to work outside of Meteor, will not require you to run on a Mongo database, right? Because there's any kind of renderer you want. So really quickly, we'll define a collection called chats so that it lines up with what's in the Mongo Lab database. And then we'll define, just like we did before, a Mongo renderer, which is going to be a function which we're going to destructure some different things off of this. So we're going to take the action. I don't know if we really need to, but we're going to take the Mongo diff. So Antares has actually done the work when you have a change in the store, so we push a message into an array, so you'll see a Mongo push operator emerge out of the backend in this Mongo diff object. So first we just have to grab it, and then, wow, the work we're going to have to do after this is going to be just really tedious. We need to grab the ID off of the object. We need to grab the update operation off of the object. We need to grab a flag of whether it's an upsert. All of these are provided for us by Antares. And then let's just look at something in the log so we know that it's done something. We'll just log that update operation. It'll look very Mongo-y, and we'll have a lot of fun. And then we'll say chats.update, and then we'll take the ID, the update operation, and the upsert. And I will not forget this time to Antares.subscribe renderer the Mongo renderer. And actually, there's one other thing I'm just going to need. I'm just going to say before I destructure that, if there's no Mongo diff, just return. There's nothing to render. We haven't detected a change in the store. So that should do it, according to the notes. So if it did, oh yeah, we already see some MDB messages. So like I said, the chat initializes itself when it starts up. Those are old errors. That's good. The chat initializes itself, and here you see that we've done a set to set it to this initial state. And we can also see that that's what it's going to be in MLab. I'm going to use this view switcher soon to indicate like which user I'm typing as. So right now I'm typing as self. Hey, from self from React Chicago. Woo. And then we will go to this remote database and do a refresh. And sorry for the color scheme there. Oh, we don't see it. We did see, oh, you know what? I need to actually stop the server and restart it because I provided it environment variables. It was writing to its local Mongo. Now it will start back up again. I'll have to type this message again. I copy and paste it before it. All right, wait for that to start. And paste from self from React Chicago, and then I'll go to Mongo Labs and refresh this. And it's still not going. I knew if something was going to go wrong, it was going to be in the Mongo URL.
Are you actually saving it though, because you just got the Mongo diff? Or is the Mongo diff what Mongo's already done?
No, the Mongo diff is going to be what, it's going to be this thing right here.
That's what you want to save to.
Yeah, it's going to be the operation.
I'm not sure that you're saving it.
Yeah, let me see my package JSON. Mongo URL equals demo, echo, demo, Mongo URL. That's legit. Collection chats. Record is chat demo. Fresh. Alright, let's look at the code again. So we're in server.
Does it case matter? Your collection chats, there's lowercase chats?
Yeah, that's that could matter. Yes, that could matter right there. I bet you there's a collection called chats with lowercase c that has the message that I wasn't just checking, but you're probably right there. Oh, and I got to do some stuff again. Please don't fail me this time. Oh, all right, refresh. Please don't fail me this time. So, all right.
That was intense.
Huh?
That was intense.
It always is. I had these animated GIFs that I thought I would just put them up and pretend I was typing it. All right. All right. So what did we learn from this about renderers? You can do client-side renderers, server-side renderers, writing to Mongo, just another render, writing to whatever database, just another renderer. Hey, what's this? Other than comic relief. It's async cat. Async. This is async too. How? How do I mean this? You go to a restaurant, right? You place your order. Your order gets, the waitstaff takes your order to the kitchen. You know what you'll never ever see your waitstaff doing in a kitchen? Standing over the kitchen, being like, is it ready? Is it ready? Is it ready? Is it ready? So why? One, it ties both parties up. It's silly. It's micromanaging. It's rude. Async is better because it frees both parties up. It frees the server, the waitstaff up to go back and take more orders. And it frees the kitchen up to do something intelligent, such as batching the Monte Cristo sandwiches that all got to be grilled at the same time. So although it's been taken as gospel that you write to your databases synchronously, I don't think so. I don't think that's necessary. I think it really depends on the application, and you should consider that. So this is the metaphor to think about when you're writing to your database. So we're already ahead of schedule. I'm probably going to finish this up early, like Raghu, but I actually have a lot, so maybe not. So basically, renderers are the only difference between applications. So I was talking with some friends about applications that do robotic brain surgery or maybe launch nuclear missiles. And like, would you be afraid to make an app like that? I wouldn't. I just wouldn't be in charge of the renderer. Like, I'll write the state change. Like, if it needs, on this Arduino thing, if it needs pins 2, 5, and 6, launch the missiles, I'll put something in a store with 2, 5, and 6 with booleans true, but you write the renderer to make that thing a reality. I'm just the app developer, okay? So I think most apps are identical, though their renderers differ slightly. Wow, this might be a little too much to drill into every little thing on this box, but I'm expanding the architectural diagrams a bit and giving me an excuse to fire my lasers a little bit more. Pew, pew. All I'm going to say about this is that user actions go into the system, eventually get written to the user store and update the view on the client. The server has a method endpoint on which it receives actions from users. They flow down like this all the way across the divide to the server, and then they come in, and we have a reducer on the server, and then we take the diff of the state stream and write it to the database, and then maybe we send things out the publisher. So, but you notice that these things, they just chain in an endless chain of isomorphic applications, passing actions to each other. So that's how we get eventual consistency. All right. So everything should be a stream, right? Well, once things are a stream, what's really powerful is that you can query or change the stream itself. So that example I said earlier, what orders came in, what requests came in while I was processing this request? If you had a request stream, it'd be very easy to answer that question. And another thing that it's helpful to have streams for is like the typing indicators. So let's see if I have a screenshot. Well, I'll just live code. This is live coding, right? So let me fire up another browser, and so the view, this guy's viewing as self, and we'll leave it that way. This one will view as other one. So you notice the messages you sent are on the right, and they change depending on who's viewing it. So now other one is typing. It's like, hey, I'm typing. Well, you don't see a typing indicator yet, so we're gonna have to fire that up. And to do so, I'm going to show you. I'm going to let you in on something. So just so as you're looking at this, the left two windows are connected. The right top one is the remote host. Okay, so when we go to Redux DevTools here, I'm going to type a little bit, A, B, C. So you're seeing typing events. So I've opted to dispatch a local typing action each time a user types. But nothing's on the wire, you're not seeing typing indicators. That's what we're going to get to with this concept of epics. So I should probably mention the Redux observable library from which I lifted the term epics. There's stuff at the end of this that shows all of my influences and stuff. So, but let's just get going on coding some epics. So we go to a file called epics. I just have a function that's been written yet, but it's not being used. And okay, so let's see. The first epic is notify of typing. Oh, this is fun. This is fun. So in order to notify of typing, well, we have to take in a stream and return a stream. So this is a pretty uninteresting returning of the stream. What do I got going on here? Some endless loop. That's not good. Let's start this over. Oh, I don't think you can do that. I think that's bad if you just return the action stream. What we're going to do is, let me just do the complete version of this. So you're going to receive your stream of actions, and you're going to say that when actions of activity.type arrive, we're going to map them to, so we're getting the activity.type action in this thing called trigger action. It's the action that triggers an epic. So a trigger action occurs that matches that filter, and the trigger action is going to do the following. It's going to return a new object, and it's going to be actions.activity.notify of typing, and then we're going to provide that. So we need to say who's typing. Well, I'll show you the activity type action. It includes who you're currently acting as, and so we just have to take the sender off of the activity type action and put it in the notify of typing action. So that thing should be reloading now once I fire this up again. Async cat. So let's see, so this one is self, and I'll turn this to other one so we have a real conversation. And then I'll type a number here, and here is the type action that has a payload of the sender self. So the epic is not yet working to create a notify of typing action, but we're going to do that in just a second. It's probably something obvious I forgot. Actions, map the trigger action to activity, activity. Oh, there's an error. I should have saw it in the console here, those 6 things. Let's clear that out. A is not defined. Trigger action is whose payload I'm taking the sender from. All right, let's the thing reload. Clear that out. Look at a Redux store, and here I typed, and a notify of typing action went out over the wire, and it should have made it to this guy. It did make it to this guy, except I didn't have my side switched. So there, I'm other one. Let's reload this. It'll be gone, and then I'll do this again. Type, notify of typing. Other one. Darn it, I gotta do this. Other one. See, there it is. There's the typing. Pretty cool. Now, if I type a bunch, it'll send one out for every one, and that's silly. That's too much network activity, right? Like, so let's just insert something really cool in here. Throttle with time, 1,000 milliseconds. So now we have just reduced the flow rate of that stream down to 1,000 milliseconds, and A, B, C, blah, 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 blah. You see how there's several types without notify typing going out? We've throttled the stream. Hey! So that's an epic. Your streams are first-class entities. You take a stream, you return a stream, you can return a transformed stream, and that will allow you to notify of typing. It's not enough to notify of typing, right? That thing is there forever. That's no good. You got to get rid of it. So what are the conditions? Does anyone here use chat on SMS? Is anyone using chat on SMS right now? How does your typing notification go away? What are the two conditions which it goes away? You get the text from that person. They were typing, then you got it. Okay.
They stop typing.
Or they stop typing, or they get hit by a bus and their phone goes into oblivion, and you just don't hear. You don't hear from that. You don't hear from them that they've been typing. So, so that's what we're going to do next. All right. So I have a little helper function, create cancel action for, which takes a sender, and I didn't really call out that the notify of typing has an active flag, true or false, and so to set it up, I didn't really call this out, but notify of typing, the default is active, but really we could have been explicit here and been like sender is blah 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 active true. So notify of typing, to create a notify of typing action, we'll just set active false. We'll also call it a local only action. Local only actions don't go out to the server. So basically, I don't need to tell the world that I canceled your typing indicator. I just haven't heard from you in a while, so I canceled your typing indicator, but that's not an announceable thing. It's not worthy of announcing. So it's a local only action. So that's a helper to create a cancel action. And then there's one other helper that I'll write, and then I'll tie it into a new epic. And it is the, scroll down, const dismiss message from helper, which will take a sender, and it will return. So basically, it will say anytime. Where do I get my actions from? What's that? That's just going to work. I don't know why that works. It might fail. We'll see. So actions of type oh yeah, I think that's going to fail. Yeah, you know what? I have to define that in a different location. So we're going to do a new epic here. Dismiss typing indicator is going to take a stream of actions, and it's going to do some stuff before it returns a stream of actions. So it's going to declare a helper. I need a comma. Actions of type activity. No, actions of type message.send. So we're interested in dismissing a message from a sender. So we're going to look at all message.send events that we get. We are going to filter them such that the action, we only consider the action if the action.payload.sender is equal to the sender that we want to dismiss the message from. And when we do have a matching message from that same sender, we are going to map it to that create cancel action for the sender. All right. It can be a little bit hard to read and write this stuff, but I hope as I talk it out, you hear the reasoning in my head, and that the reasoning sounds pretty straightforward and logical, even if the exact syntax isn't. So we've declared a function which can cancel an action once we receive a message sent from that same sender. Then we will return we're going to get actions of type activity.notify of typing. And when the notify of typing has been turned on, so when active is true, what are we going to do with notify of typings where the action has been turned on? We're going to do a fancy little thing called switch map, and we're going to take the trigger action. So the action that just notified us that somebody is typing, we're going to take that action, and we are going to return dismiss message from, and then let's see, this in 2 lines. From the trigger action payload.sender. So if this works, it'll be but here we are. We're restarted. I'm going to remember to be other, and I'm going to start typing.
No errors.
What's that?
7 errors.
7 errors, correct. Thank you. Unaccepted. So those are old. This is sometimes you have to reload both browsers and dismiss the errors. Thank you very much. So this guy's going to be other one. And A, I'm typing. All right, we got a typing indicator. B, still typing. And then I send the message, and the typing indicator is gone. So yes, you can applaud. Yes, please. Yes, thank you. You are my friend. Thank you so much. Yeah. So by having streams, we're able to query the streams, do stream foo to figure out when to cancel a thing. And streams, or they're actually known as observables in RxJS, they can embody time. So now we get into the coolest part, I think, which is coming up with our last helper, which is just time out the indicator. Time out that typing indicator for a given sender, right? So time out the indicator takes a sender, and it returns, what does it return? It returns a observable timer 2500 that then gets mapped to create cancel action for sender. So instead of dealing with set intervals and set timeouts and keeping track of interval variables and canceling timeouts, RxJS has bundled all this stuff into nice logical things like timers. And so the timeout indicator, which we're not using at this moment, will, after 2500, once it's invoked, after 2500 milliseconds, will dispatch a cancel action. That should work nicely with our 1000 millisecond throttling. And then down here, where I said the trick, well, let's just see if we haven't broken anything. So we're not using timeout indicator yet. So let's just refresh both of these, become other one, and things are still working, but they're not getting dismissed. I think I've done this. They're not getting dismissed until we send, but the sending dismissing is working. So instead of doing that, we're going to do the following. We're going to say observable.race, which means the first to complete of either the dismiss message from, so either you first got the action and canceled it, or the timeout indicator for trigger action.payload.sender. All right, so the syntax, obtuse, hard to understand. The concept, pretty straightforward. Either you get the message and cancel it, or it times out and you cancel it. And a man will have to be right there on applause, and Shabam too, when this goes down hard. Trigger action is not defined. Why is trigger action not defined? Trigger action. I've been inconsistent with how I named, what line is that? 38. Trigger. Oh, syntax error. Just straight up syntax error. And then switch map needs to close. All right, there it is. Clear that. Reload this. Other one. That reloads. Clear the errors. Okay, so I'm self another one. I'm typing, and I send. It goes away. All right, we saw that. I'm typing, and I send. I'm typing, and it times out. Whoa, drop the mic. Not really. Not really. It says no mic drop. All right. Is that cool or what? This is how we're actually building apps, actually building production apps. We generate our database / whatever statements automatically. We're confident we can port to another database platform because, heck, there was only 5 lines that hooked up the app to a database to begin with. I found some chat rooms and resources that have been really super helpful in learning this. I've included them at the end of the slides. Maybe I'll just a question or two right now, and then I'll get to the wrap up. Bill, you got a really fun look on your face now. All right. So yeah, this is real. I love it because it is. I don't know. It's a really nice platform. I think this helps us to build the apps of the future. And here's a few catchphrases to show you what I think the apps of the future are. I believe that if you can edit it, it ain't data. It might be a cache, but I don't know. That's this guy who wrote a book called Common Sense says that if you can edit it, it's not data. It works for Google Analytics, so it works for me. It works for Git repository, so it works for me. My friend Anthony paraphrases say, the truth is in the action. As soon as the customer originates that purchase order and it's in an action, the source of truth isn't in your database. The action is true before it makes it to your database. You just haven't gotten there yet. The truth is in the action. That was Anthony. Not all apps need a database. Not all events need persistence. I don't know, it's not very funny. But my friend Ben is a little funnier than me. He says, async is cool, yo. It's how shit works. He goes out to restaurants a lot, and he noticed that thing, how restaurants are async. So that's pretty much it, man. Like, the next steps, please, check this out. Download the repos, run it. You currently need Meteor to run the server part. Don't let that stop you. It's a one-line install. Help me port this to any Node JavaScript backend. It's not that hard to do. It's doable. Read the docs. I have links to both a wiki in the GitHub repo, and I started a Git book. Like you started a site, Raghu, with like your stuff. I've started a site. It's a bit of a mess right now. The repositories have the best documentation. Like really, like please try this out. I think that this can build killer interactive apps, and I want Chicago Backstop React Chicago tonight to be the start of this for all you guys. So thank you very much.
Question.
Raghu.
So when you listen to an event from the WebSocket, and that triggers a renderer, can you show that how that works?
You listen to an event from a WebSocket and it triggers what?
A renderer?
A render?
A renderer.
A renderer, yeah, okay.
So when you get a message, a chat message, incoming message, that's a trigger, right?
Yes. So the client, so anytime you do subscribe renderer, this function will be called once for every action that this process sees.
But how is the message actually displayed there? So you have,
how is the message actually displayed? Okay, so I have a Redux store in this, and the Redux store is keeping track of these messages, and then I'll send this one, and it gets appended to the store. So in this repo, I'm using vanilla like connect, Redux, React Redux bindings to sync React to the store. Actually, in the production app that we're doing, we're not using React as the front end. We're using a different view library entirely. So it'll update the store. It'll give you events for every action in the store, and then in this one, the store is just bound. Let me show you that file. It would be the file live chat. So live chat has a map state to props function. It gets the state from the store. It defines the rendering methods to iterate over them, just like loop over each message. And then there's a connect map state to props thing that uses the Redux store. And the client index gives you reference to the Redux store right there on a prop. So it's just vanilla Redux React bindings. But like I said, we don't use React and Redux at work. So you can just, so that's why I didn't have to write a renderer function to do this. But in the production app I had to write a renderer function because it's, a different view library. Good question. Yes?
So do you use something other than Antares to bootstrap your initial state? So for example, if everything's based on events, right, and I want to get a history of my chat when I reload the page.
Yes. Yeah, that isn't in this repo, and that's why you saw the chat restarting every time the process restarts. So yes, it's easy. In the console, the server console, we see a message. We probably haven't seen it in a while, unless I reload. When I reload, you'll see a message. Let me reload a few times so that scrolls higher so people in the back can see it. But you see we have this event that says, this subscriber, this subscriber is interested. The key that they're subscribing to is the chats collection. Chats demo is the record. So since we are rendering each new chat to a Mongo record, we can just hook on that event and say, oh, you're subscribing to this. Let me give you everything that happened up to this point. And it actually comes through in the form of an action as well. It'd be the very first action that Antares sees. There's an Antares.store action, and that means like start yourself off with this record. Store this record at this amount, and then you can go incrementally by actions as you go. Yeah. So there's some room to improve the way that works in Antares. I'd be interested in your input, but that is accounted for. Yeah. Good question. Joe, you have a question there? Sorry.
I guess I do have. So one question is if action is state of truth, can you reverse an action?
Can you reverse an action?
Let's say it's at, right?
Right.
Multiple things. And then
Right.
reverse one of the actions.
That's a really, really good question, Joe. I used to work with Joe, that's why I called him out on that. So I didn't explain that this can use optimistic UI. And it does, in fact, use optimistic UI. I don't have it handy where I can insert 1 second delay in the server process. I don't have it handy where I can insert a delay and show you that the UI updates automatically. But that's what your phone SMS apps do, too. They update the UI right as soon as you send a message. And what happens if a few seconds later the network decides that didn't go through? It sends you that little exclamation mark icon. So that's an additional action. So it's called compensatory actions. And so you have to, like, if your system is operating knowing that, the action is the state of truth until it's not. Well, as soon as you discover that is for some reason a bad action, you have to send something back to reverse it. So that's another thing that has room for improvement in this repo. You won't see much of that in this repo because it's very application specific. So for example, there's different levels of, because this is a distributed app, the first thing is, did the server get it? And you could wait all the way until the server gets it to integrate it into the UI, but optimistic UI says, integrate it, like show it in the UI right away. Then if the server says there was a problem with it, then you can have a promise handler for the dispatching of that action, the sending it to the server. You could, do some stuff there. So there's different points in time at which you could, manually revert the action. But that's what you'll have to do, is dispatch another action that cancels it. So good question. All right. How are we doing on time? Good?
Yeah.
All right. Can we mingle and have some Mountain Dews and beers and
Yeah.
take
Do
it?
it.
All right. Thank you all.